Have you ever sat inside a massive sports stadium, looked around, and just wondered, how on earth did they build this? Well, today we're going to pull back the curtain on the incredible unseen science and digital wizardry that makes these modern marvels possible. And here's a hint. The most important game was won years before anyone ever stepped onto the field, and it was won on a computer.
This quote right here, it just nails it. It's such a powerful idea, right? The safety of 80,000 fans, the perfect angle for the TV cameras, the sustainability of the entire building. All of it starts not with steel and concrete, but with pixels and data. The real action truly begins in that digital model.
Okay, so here's our game plan. First, we'll talk about the big idea, the why behind it all. Then, we'll dive into the digital blueprint itself. After that, we'll see how that blueprint actually engineers the arena, look at what happens long after the ribbon is cut, and finally, we'll give a shout out to the unseen champions who make it all happen.
So, before we get into the nuts and bolts, or I guess the bits and bytes of stadium design, let's start with why we even build these things. Why do they matter so much? Well, it turns out the roar of the crowd is connected to a much bigger global mission. Our story actually starts right here, with the UN's International Day of Sport for Development and Peace. It's this great reminder that sports are kind of like a universal language, right? A tool for bringing people and communities together. And, well, every community needs a place to gather. And that's the connection. That's the whole point. For sport to live up to that promise of peace and unity, the arenas themselves have to be safe, they have to be sustainable, and they need to be built smart. You just can't inspire community in a place that's dangerous or wasteful. This is where engineering becomes the silent partner to that big global mission. Okay, so how do you build these massive structures intelligently? The answer isn't just better cranes or stronger steel. Nope. It's a revolutionary digital technology called BIM. So what in the world is Building Information Modeling, or BIM? First off, forget thinking of it as just a 3D drawing. It is so much more than that. It's more like a complete digital encyclopedia of the stadium. Every single piece, from a huge steel beam down to a tiny electrical socket, is an entry in that encyclopedia, and it's packed with data. It's a living blueprint that grows and evolves with the building for its entire life. And this is why BIM is such a game changer. You see, the old way involved piles of flat 2D drawings. The structural plan was separate from the plumbing plan, which was totally separate from the electrical. If an architect changed one thing, you'd only find out about the conflict when, a plumber and an electrician showed up on site trying to put two different things in the exact same spot. Yikes. With BIM, it's one integrated dynamic model. You move a wall, and you instantly see how it affects every pipe and every wire. It's all about catching those problems before they even exist. All right, so we get it. BIM is this super smart integrated model. But how does it actually help solve the absolutely mind-boggling challenges of building a modern stadium? And believe me, the challenges are immense. We're talking about roofs that have to stretch hundreds of feet with zero columns for support. We're talking about moving a crowd the size of a small city in and out safely in just a few minutes. And the internal systems for air, water, and power, they're more complex than an entire city block. It's really a symphony of controlled chaos. So how do you build a roof that looks like it's defying gravity? Well, you use something called parametric modeling. Think of it like setting up digital rules for the computer. Engineers can tell the BIM model, hey, this roof has to withstand 100-mile-per-hour winds and 2 feet of snow. Then the computer can digitally test thousands of different designs to find the one that's not only perfectly safe, but also uses the least amount of material. That saves a ton of money and resources. Now, this is where BIM gets really, really clever. It adds a fourth dimension, time. So before a single shovel even hits the dirt, planners can build the entire stadium virtually, week by week. They can run a simulation and see, wait a minute, the plumbing contractor is scheduled to show up before the steel frame for that section is even finished. It's about choreographing this billion-dollar dance of people and materials with digital precision so you avoid those super costly delays and clashes on site. And what about actually being inside? All those hidden systems that keep you comfortable and safe, that's the mechanical, electrical, and plumbing stuff, or MEP. They're all coordinated perfectly in BIM. Engineers can run simulations to make sure the AC can handle a full house on a blistering hot day, or that a smoke extraction system could clear a whole section in seconds if there's an emergency. It even helps them get the lighting and acoustics just right so every fan has a great view and it sounds perfect for everyone watching at home. But here's the thing. The BIM model's job isn't over when the stadium opens, not even close. In fact, you could argue its most important work is just getting started, shaping the building's legacy for decades to come.
So now we're going to add even more dimensions to the model. We're leveling up to 6D, which is all about one thing: sustainability. With 6D, that digital model basically becomes a sustainability lab. Before it's even built, engineers can analyze how the building is going to perform environmentally in the future. They can tweak the design to let in the most natural daylight, which cuts electricity costs for decades. They can simulate rainwater collection systems to see exactly how much water can be saved. It's all about making these massive buildings as green as the fields inside them. And that brings us to the final level, 7D, the seventh dimension. This one's all about managing the stadium, not just for opening day, but for the next 50 years of its life.
This is such a cool concept. The BIM model becomes a true digital twin of the physical stadium, and it's linked in real time. So imagine you're the facility manager. You can just point your tablet at a light fixture way up in the ceiling, and on your screen, the digital twin instantly tells you its model number, when it was installed, and exactly when it needs to be serviced next. It's a living, breathing instruction manual for the entire building.
Now, with all this incredible tech, 40, 70 digital twins, it's pretty easy to think that robots are just building these stadiums now. But the most important piece of the puzzle is still the human one. This is all about brilliant people using powerful new tools to do what once seemed impossible. So, who are these unseen champions? Who are the people making sure our favorite teams have a safe and absolutely spectacular place to play? Well, they're the structural engineers, the digital modelers, and the project planners. They're the experts working behind the screens, running thousands of simulations, and solving problems in the digital world so they never become multi-million-dollar headaches in the real world. These are the people who really build the arena, and they definitely deserve a round of applause. And this quote right here, it just perfectly captures their entire philosophy. The goal isn't just to make a pretty 3D model, it's to engineer performance. The performance of the structure against wind and weather, the performance of the building systems for the crowd, and ultimately creating the perfect stage for athletes to perform at their absolute best. So, the next time you're in a stadium, or even just watching a game on TV, I want you to take a second and look past the action on the field. Look up at that massive, soaring roof. Listen to the crispness of the sound system. Feel the comfortable air. Because now you know about the invisible engineering that makes it all possible. The only question is, what else will you see?